So yeah, we'll start the class. So can someone say like at least can I just list out the topic like what have we seen till now? Like can I just like quickly summarize or list out the topics? I mean in the chat box itself. No need to like turn on the mic or something. We'll start up with today something with sequential architectures. Sorry, anyone please? Am I audible, right? Yeah, yeah. So someone please, yeah, Krishna, can you just like tell the topics like what have we seen till now? Just list out like the name of the topics alone. I think in the starting we have seen something called. I mean, like we have seen the pre-processing steps, which has been useful for your project. Actually, I've seen your project span classification, which is like most of the steps are like data analysis only, and then pre-processing steps. And then they have explained some two algorithms, gradient boosting and then random forest. We'll see. Oh, those are all some ensemble techniques we will be seeing today about that. And then some sequential architecture, something called LSTM, GRU. Like Lognia, I mean, like basically the text is basically called as your sequential data only. If you feel like if you take a sentence, mean like word by word will be processed actually. So at each time step. Actually, let me share my screen so that would be like better for you. It's my screen visible. Can anyone? Okay. Able to see the screen fully or the chat box is hiding the screen somewhere around. Okay. Okay. Yeah. So I was saying about this RNN families, all those things like sequential architecture. So basically, how um, see, like basically, if you are like reading a whole book, let's say you are reading a book, huh? You are like completed some 10 pages actually. Huh? So, and then like while reading the 10th page, you'll be like, what happened in the last 9 pages? You'll be like facing some issues, right? What have you read? Okay, okay, I got it. Like so many. Oh, if people are leaving, okay, fine. Someone is leaving. I think I hope so they'll join again. Yeah. So you're reading some book and then like you have crossed some 10 pages and then after crossing some 10 pages, you'll be like you'll be having a least amount of memory on like or store. I mean like could able to remember what have we seen in the page one actually. So in that case, like it's like something called like you are like forgetting what you are like seen in the past data. Huh? That's quite human tendency. I mean like not like a very in the first 10 page we could say, but then, like while reading a whole book, you'll be like giving attention to something else and not to some other thing. In that case, like somehow the architectures are like very like underperforming on those cases. So that's why like sequential data, this sequential architecture came into this picture. If you see, means like this sequential architecture, like it's very good in what we could say in processing text, audio, or video, or whichever. Like because video, if you see, like it is doing frame by frame, a text means like a words by words. Audio means phonics by phonics. So these RNN families are good for this holding this contextual information. So we'll see like how this architecture is working. So basically, this is a feedback network. If you see feedback network in the C means like in the it will be a basic neural network, and it will be like a lot of hidden layers will be there. Some input layer, some output layer, and like some n number of hidden layers will be there. In these cases, only like only one forward layer and like I mean like a same n number of hidden layer and those cases of output layer. But then In this, it is like the output of the first case will be fed as an input to the second case actually. Uh, so it is basically what you call a rollover network. So it is like a feedback, right? So your output of one network is again fed as an input to the second network. If you see, if you people are from electronics background or something, um, yeah, you would have read about this flip flops and all. Like you will be like feeding as output of one block as an input to the next block. So hold as a memory retention. So the same case, that's what happening here. So in this, like if you see the first step, I mean, in this example, let's say by an example actually. In this example, my class is the best class. So as I said, like the architecture will process word by word. The first word will be fed as at first time step C naught to the RNN architecture. Sorry, can you just hold on for a moment? My laptop is getting, I mean, like discharging. Hello, am I audible? Okay, it seems like I was in mute actually. Okay, okay, okay. So till now I was explaining the RNN. Did you people understand anything on that? I mean, like, can some I was like, yeah, at least like I was explaining some like some terms, right? What is the RNN? I mean, like sequential architecture. Are you people understanding like what I was teaching till now? So if someone responds me, that would be like more better actually. Okay. So, so yeah. Um, so yeah, so as I was saying, this architecture was facing some long-term dependency problem. What is this long-term dependency problem? If you see means, to up to certain extent, it can hold the information of the past time step. But if the sentence length is of to a greater extent, some 20 to 30 words, it will forget the past information. So in this fast information, how can we still retain this fast information? That's the problem, right? Huh? So we'll study why this. So in order to solve a problem, we should understand like why this problem is occurring in the first instance, right? So why this problem occurring in the RNN? It is occurring due to something called vanishing gradient. Vanishing gradient is nothing but see, I was explaining you about this gradient descent, right? In this gradient descent, you'll be like doing a different, I mean, basically differential calculus. You're basically calculating the slope. The slope is nothing but differentiating your independent variable with respect to your loss function. Or like not independent variable or weight parameter with respect to your loss function. So in order to reduce the loss actually. So that's what you're doing. And for adjusting the weight, so in order to accordingly to give the proper prediction. But then in the last layer, if you're doing it, but then like over the time in your back propagation, if you're going to the past layer, second, I mean like in the initial layer, starting layer, first and second layer, in that case, what happens means it will lead to a converging point actually. Converging point means after over some time, the weight will not update. So a good example is I mean, like, not example, like what it exactly happened. For example, you are differentiating, doing a differentiating x square actually. X square differentiating will give you 2x. Again, if you differentiate means 2, right? Again, if you differentiate, constant. Again, 0. Again, if you differentiate, 0. Again, 0 differentiate, 0. So it will be like how many times you differentiate 0, it is going to give 0, right? The same thing is what's going to happen in the RNN also. In the back propagation, you are going to differentiate the weight variable I mean weight parameters. After some two to maybe like after some 10 differentiation, it is going to go to some constant value and it is going to stay in that value itself. I mean like more or less like what we said for the example of x square. So it is going to stay constant and then the weights are not going to update it. If the weights are not getting updated, it is going to lose the past contextual information. Lose the past contextual information. That's what happening in the RNN. So that is something called that's your vanishing gradient problem. In order to train the network, you back propagate through time. In that time, you're losing the past contextual information by not updating the weights. Yeah. So this problem has been overcome by something called GRUs and LSTM. And GRUs and LSTMs, if you see, means like in order to hold the memory content, we are seeing something. We are adding an extra element, something called gates. Gates. This what. So what this gate or I mean like gate layer does means it is like it is controlling the flow of information in your architecture. What it does means like for example the name itself signifies reset gate is going to reset and update gate is going to add something new. So in your first layer, second layer, third layer after processing these many time steps, okay. it is like, let's say like if we are in fourth layer. So in the fourth layer in this block, we are trying to process what is happening in the third second, what kind of information has to be like carried over for the next fifth layer. So the reset gate will tell what amount of information, like what are the kind of irrelevant information till now what are the kind of irrelevant information that is there till now we have got. So that like so if it is an irrelevant information, means that is unnecessary for the model to take into it, right? So the reset gate will like forget about it, will delete it actually. So reset so in the first layer, second layer, whatever the unnecessary information, the reset gate will reset into zero. And the update gate, what the update gate will do means update gate will update the current information with respect to the past information. So let's say I am in the example sentence itself. The cat is running fast. While crossing the word fast, the forget. I mean the reset gate will tell whether should I retain the information about my cat is all these three words, and then update gate will tell what is the relevant information that I needed to predict the next word fast. The cat is running fast. So in order to predict the word fast, the update gate will tell what is the relevant information from the past words. That's what your update gate does. So the LSTM also is the same, but in the only difference is the architecture wise. I mean, architecture wise means what we could say means something called a cell state will be there. I mean, like no need to worry about that much actually. I mean, basically everything is like basically updating your activation function, adding one more layer. Uh, I mean, like adding some extra components. That's what you're doing in this all this entity architecture. So basically, what is the main difference or main point that we are trying to understand is RNN is all a sequential data, sequential architecture that process words at each time step, and then like holding the past contextual information, and then the disadvantage of RNN is vanishing gradient problem. The vanishing gradient problem is being overcome by your GRUs and LSTM, gated recurrent units, and long short-term memories. So yeah. So is it okay? Can someone respond? Okay. Do you have any doubts on this? Yeah. If you have any doubts, means like we can discuss on that. Like because I've taught you like in a moderate level. If you want any like any in-depth nuance kind of detailing that you want to get it to know, like you can tell up on that. So how we people started the projects. So next we'll start seeing about this something called gradient boosting, which you are using in the what in your project spam classification. So this, as I was saying, this architectures can be used in like many applications, something called mission translation, like your source language will be one you're trying to convert into another language, let's say like English to Hindi or English to Tamil. Uh, this RNN will be like used as an encoder decoder architecture. So you're like you'll be encoding information, you're encoding your source language in one representation, again trying to decode that representation in your target language. So yeah, any doubts on this? No doubts. So yeah. Mm, So you people have someone said like if it's I mean like started with spam classification. So in your spam classification, this is the classifier that has been used, right? So probably someone like who are doing those who have started I mean like spam classification, they should get to know about this gradient boosting. Can someone ping in the chat what that is like? I mean like what is the basic mechanism that is like lying behind this algorithm? No response. Okay. You people are not responding or not being impacted. Yes. Okay. Yeah. So your grading boosting is nothing but it's a kind of ensembling technique. In your ensembling technique, if you see means like you're basically trying to get a more number of flat space and to construct a final large model. And then I mean like large, not the large model, a final like a conclusive model to get a better output. So a better classification performance. So what your ensemble does? Uh, I mean, basically, if you would have seen about like a lot of, I mean, algorithm like a kind of decision trees or something, linear regression, logistic regression, and like a perceptron algorithm, MLP, a lot many are there. Huh? But then these architectures like are some like might face some issues. Issues in the sense like overfitting or underfitting. Underfitting is like can be overcome by with better balance in data set or something. I mean like that relates to your I mean sample size or something. But then overfitting problem occurs. That is also related to your samples only. But then predominantly based on your architecture wise also it can happen. What this overfitting problem is during your training time it can perform better, but then in your testing time it can like give a poor performance. I mean, like it is not generalized very well. Let's say like you have studied for the examination. You're studying for the I mean like for NLP itself. Let's say you're like listening to the lectures and then like you have got all the content. You're like very good in that. Huh? You're like what like from the topics like whatever I'll give some question in the class itself from that but so you very well read that question you can answer whatever the question that comes in the examination only the question that I've given in the class but then if I like slightly rephrase the question or like slightly ask the question from out of the book but then in the same topic if you're not able to answer that question means that mechanism that something that phenomenon is called overfitting. Basically you are able to learn whatever I taught but then you are not able to learn on your own. You are basically better fitting to the whatever that is there in the syllabus, sticking to the syllabus. I mean basically to the blueprint, basically what you do in the final state of the examination, right? You'll be there just studying the one day before the examination and then like mugging up and then like going to the class and like just like spitting it out. And like not everyone, like in some cases like in that way but then like if I ask some general if someone asks some general questions about like kind of the nuance detailing in that case like if you are not able to I mean, like answer upon that means like that is your like overfitting problem. The same happens in the machine learning itself. If you're not able to like generally give a generalized description for your sample data set, that is your overfitting problem. So it is something called bias is low, variance is high. Variance means like as I said, like training loss is low. I mean, testing loss is very high. You're like varying a lot from the practical scenario. So yeah, this problem has been addressed by this ensembling methodology. What your ensembling means? This so basically the classifier that is doing giving a better training accuracy and like poor testing accuracy. We can say it as a weak classifier, right? So it is giving a weak performance. So like by combining a lot number of weak classifier to one, combining means like one some summing up a combination of some fourth n classifier. I mean 4 to 5 classifiers by building one classifier. It is giving a it will give a strong classification performance. So that is called your ensampling combination of some weak classifier. That's what your definition. So some architecture is like a if you're bagging and boosting. So under this bagging means will be like collecting as I was saying large number of weak classifiers and finally get the average of all those Boosting means you're giving a sequentially. And your sequentially means like one by one, actually. You are getting an output of what first base model and then feeding it your like the next again weak classifier, getting the output, again feeding that to the next weak classifier and getting the output. So it will keep on boosting your performance, right? If you keep on increasing the number of layers, if you as a layer by layer, I mean like the number of layer increases, your performance is getting boosted. That's what you're boosting. My gradients are getting boosted to better fit to the my sample data set. So how this algorithm works, we'll see upon that. So basically, this is my data set. Let's see. In this data set, if you see budget and box office, uh, yeah, we can say box office. Yeah, box office is your labels and number of stars and budget. It's your like independent variable. I mean features. So based upon that is your data set. Let's say based upon that, I'm feeding this data set to one model. Okay, I'll give you this way. So yeah, this is how your gradient boosting algorithm is like. I mean, like basic visual representation could be. If you see, you have drawn something, right? Your base model and passing it to decision tree one and passing it to decision tree two. So let's say in the same case, he has given some tabular columns. Some experience and degree is your independent feature, and salary is your dependent feature. So I mean, like I'm showing this video just for only for the this visualization purpose I've shown you. Again, we'll go back to this like what's happening. Um, yeah. So in the initial stage, for the sample data set, I'll be passing to my base model. In that base model, I'll be getting a prediction, right? A y hat. Y hat. Y hat will be there. Again, my original truth, ground truth will be there, which is the box office. Uh, box office. So let's say initially, if I give only one model, the cost function for this ground truth and the predictions might be like very perfect for a training case as I was saying, and then will be like a poor for testing case. So in order to do that, we'll be like adding some, we'll be like penalizing the prediction. Penalizing means we'll be like adjusting the weight accordingly. So if a person is let's say if a person is doing a wrong thing, we'll be like sitting and then tell him this is wrong, this is right, right. Or like in worst cases, someone will beat him up to make him understand which is the right thing. So in the same way, we are like, putting fine. I mean, like if you get it caught up by a police person for violating the traffic rules, you will be like putting a fine, right? I mean, the same way. So you will be like putting some regularization technique to penalize the your prediction value. So in that case, uh, it will be like very far away from your target label, but then uh, for the base model, it will be very far away from the target level, but then we can still like make sure that it is going to give a bet. I mean, like near to the target levels by getting some good prediction. How does it do, means this residual one is there, right? Okay, after calculating your box office, I mean, like your ground truth and your prediction, the difference between your ground truth and prediction is your error rate, right? Your error is something called residual. Residual means like what is left out. So that error is calculated for your first base model. So now for the first base model. Now after calculating the residual, this ground truth will not be considered right now for for your second base model. For the second base model, how the data set will be fed as this independent features, and then label as your error rate, this residual one. Now, this actual ground truth will not be fed as target labels to your second base model. Residual one will be fed as an target label for your training data set for your second base model. Again, you'll be like getting a prediction. From that prediction, will be calculating the error rate. That error rate will be fed as a target label for your third base model. So in that, like we'll be doing a sequentially. by doing it sequentially, yeah, will be like initially in the first base model, your prediction will be very far away from your actual label. But then if you take it to the last base model, you're like over the, I mean like over the layer by layer, your prediction will get moved towards your target label. So it will give a best fit for the data set. So in your residual two, if you see means, wait, I'll show you. So this is what I was saying. Your weights of the model is getting multiplied by some factor. That is called your regularization factor. So yeah, after getting, you'll be getting some individual output size for each base model. All those outputs will be like summed up and will be taken as one input as a. So that final output is your like output of your strong classifier. That's what we are doing. Summation of all residuals. Summation of all residual means previous probability. Into am, am I audible now? Okay. Okay. Someone has asked, sir, this project is long term or short term? Uh, I mean, like, what do you mean by that? Can Ginjala, Anusha, can you tell me properly or like hello, Anusha? If Anusha is there, hello, Anusha, can you please rephrase your question? I mean, like, I'm not able to understand what are you trying to ask? This project is long term or short term? Are you asking about the architectural wise or like or about something else? Are you asking about the team or something? Wait a second. Okay. Can you explain how we have to implement this gradient techniques in classification of data sets? So yeah, you are asking me to, are you asking me to walk through the code? If it is means we can see the code also as well. We'll open the code base and we'll do a cell by cell analysis. Sure. That's what you're asking. Am I audible, right? Okay. Okay. We'll see the code base. Yeah, 1 second. I'll open the code and then we'll share my screen. Okay. You're saying you are like aware of mechanisms. Okay. We'll see the code base then. Basically, in initial phase, why did we floated the project? Like means like you might be like trying on your own, and if you face any issues, you can come up with the you can come to us like what you're exactly facing. That's why like we have given time to try like initially to try on your own. Anyways, we'll see the code base. Is my screen visible? I will play the chat actually. So this is your code base, right? They've given a gift repo, right? So how many of your people just like how did you pull the code base? Did the people just like copy pasted the code or like downloaded or did a git clone? Okay, initially, like whenever a Git repo is given means they are basically have to like do a cloning, basically like duplicating the original one. That's what we have to do. We are just not supposed to like download this one alone or whatever we need alone, huh? Because like if a repository contain more than some 100 files, mean then that will be like very difficult, right? So we have to pull the entire code base. What we have to do means like basically it's something called this one will be there, some HTTP URL. This URL has to be copied and go to your terminal. In your terminal, yeah. Mm, okay. Wherever you want to store the code base means you have to do a command called git clone and paste that URL. So your entire code base will be like pulled up. So now now initially inside the directory it was empty. Now it is having something. Now am I audible, right? Okay. Yeah, sorry for the discrepancies. Well, okay. One second, it's getting loaded. So yeah. So have you people started the code or not even started? I mean, like started implementing. So initially we are like doing an importing and trying to read the data set. That's what they are doing initially. Mm, Python environment, the SQL and only right. So initially what they are doing is like listing all the directories in the spam classification folder, and then getting the spam. This basically this is what they are doing actually. So my current folder is like NLP spam classification. I'll like change the directory accordingly that. Um, and then like no need to do that. Like basically they are like getting a relative path only. So I'm like reading the data, the CSV data, I mean like data frame, CSV file into a data frame and getting the data set. So like in the data set, if you see me like input and output is given. Input is a text and output is your label. Label what you mean when whether it is spam or not spam. Spam mean like whether it is I mean like it is like a needed mail or not needed. Like spam mean like unnecessary kind of spamming. So that label has been given for each text. So on top of that, they are doing some data analysis, like I mean, like data distribution analysis. What they are doing is like trying to find the pattern or like frequency distribution. I mean, like how many number of spam or ham it is there, what percentage it is present. So that's what they have written in the note. Also, in the process of performing investigation to data, so as to discover patterns to spot on anomalies. Yeah, input data rows, and so they are saying input for these many rows and two columns. Only this and all you are like self-readable, I think so. So yeah, as I was saying, this is not needed, even though it is the cell is given. Yeah. Mm. Are you people facing any particular issue in any specific segment so that we can move on that case? Or else, like, do you want me to explain the code line by line, or like on the implementation part? On the implementation part means like I can do it accordingly, or like or explanation means I can based upon that, like I'll go through. I mean, like move over the class. Can someone respond? Am I audible first of all? It's because like if people are not responding, means I'm doubting myself that like it is not audible for you people. Only for that you people are like saying. I mean, like it's okay. So there are significantly more number of spam messages than there are spam messages. So it is saying they are saying a more number of messages. So I mean the one data distribution of one class is like very high compared to the other class. What do you mean? Like the data set is very unbalanced because like one label is 87%, the another label is like 13%. Actually, in usual cases, the data set should not be like prepared in this way. So it should be like a 50-60 or 50-40. I mean, like sorry, 50-50 or 40-60. In that way, the data distribution should be there. So in that way, the model like learn both the cases in a very well scenario, in a very well manner. So this line is why they are doing means to check are there any null values are there in the null samples. I mean any non values. You know what is non values? I think so. Number of null in level, number of null in table, both are zero. So we can we can go ahead with this. If any non values are there, means we have to remove that specific non values. So next what they are doing means uh, data body and body text dot apply count function. Okay, they're like as I was saying, this pre-processing techniques, right? This basically what they are doing is removing the all the punctuation, removing all the punctuation in your data set. That's what they are doing. Count punctuation. They have written a function something called count punctuation. In the count punctuation, they are getting all the characters. If they for that's what the for character in text. If the character is in string punctuation, then it is one. Uh, so they are removing all the punctuations. So after removing all the punctuation, they are getting the some statistical values. Statistical values means how many punctuations are there, and I mean like number of punctuations on each, and getting summing of all those things, and the body length. I mean like the sentence length. Let's look at look at the body length. So this and all, it's not. I mean like this for understanding purpose only. They are telling their maximum body length and maximum punctuation. Now use the newly created features to explore the text distribution. So, are you getting this error? Can you people respond? Where are you people getting this error? Rectangle objects has no property nor met. Yeah. Basically, what they are saying is there's something called that parameter. Initially, a parameter was there, right? This normet. This parameter has been like removed in this particular library, in the plot library. That's what it has been deprecated. So it is no need to present anymore. Basically, what it's saying is plot is a normal distribution. That's what they were trying to put it as a parameter, but then it is not. Even though if you don't put, it will take it as a default value. See? So in that case, or maybe if you get an error, means we can replace with some other parameter also. Get this rectangle object as no. We'll try to search it in Google what they are the alternative that they are using. Now instead of this for normal, they are trying to say use another parameter called density. We can try with that parameter as well. Mm. Yeah. So as I was saying, the same thing. Your normal distribution should, they are trying to plot in a normal distribution. Normal distribution means like your mean should be zero and standard deviation should be one. That's what they are saying. So these are all some basic, some library issues we can like easily solve on like just taking a Google help. So if now is it fine? Yeah. You can see spam messages are a longer one, but let us continue more. Same, same thing here also. Remove this normal or tell it as density. We are good with this. Okay. We have completed the data analysis part. So now we are like trying to pre-processing steps, turning words into lowercase. Yeah, removing punctuation. Before we have not removed the punctuation, we are just trying to get how many punctuation percentages are there. Now this will remove all the punctuations in your characters. See, after this function, we are like going through this question mark and exclamation is removed. Now tokenization, as I was explaining the tokenization part, I hope so. If you people remember, that would be like very good. And removing stop words, I was saying, okay, here we are getting another issue. What it is saying means, where are people getting an issue like this in removal of the stop words? Can someone respond? Hello? Can someone respond? Where, where are you getting an issue in removal of stop words? If you people don't respond, means I'll stop the class here itself. We can leave instead of like putting my time on this. Respond, or else I'll stop sharing the screen also. Get back to any hour. Okay, then you are asked, yeah, you people haven't tried Excel 16, but then asking me to implement the code, then it seems like I am putting my effort to solve your issues. That's what, right? Yes, we'll go for I'll walk through to some extent. Okay, I think someone has completed. Okay, currently working on second assessment of sentimental analysis. Can you just ping the error? What error you are facing or screenshot of something? Okay, you people are facing this issue, right? We'll show you this one alone what it is happening. Just just add this line nltk.download. That's what the issue was. Go on like in the cell, go and add this nltk.download. I'll ping you what is the URL also. You go and read this log. I mean like in this Stack Overflow forum, they have updated. That is the reason I'm not if I like do a cell by cell analysis, this will take me some time. That's why I'm like asking what issue you are exactly facing it. I can help you on that based upon. We'll wait for because like it's very hard to like run the code and then explain you on all. That would be like not possible. If you people have any doubts or issues, you can tell me in 5 minutes. We can sit and solve it, and then we can leave. Okay, text FTR don't not have any shape. Okay, sure. Okay, you better like if you're like facing. Okay, we can do with this. You can put a screenshot in the group. Uh, wherever the issues you are facing. Okay, we'll wait for 1 minute. It is saying Spring doesn't have, yeah, Spring object doesn't have any method called shape. You have to, instead of fun, okay, fine, we'll wait for 5 minutes. What exactly the error? Can you tell me? Are you facing the same error that you are facing and that I am facing? Okay. If people are not having any doubts, you can leave the class. What error you are getting, just like blindly, if you say that you are getting error means it's very hard to help you because that is a very big code actually. Where is the error? Just at least like send me the screenshot of the error. That's what I'm asking. Okay, can you print the last hidden state instead of shape? Don't put shape. Just print the last hidden state and then type of last hidden state. Just put type. Print the two lines and show me the output. Okay, one thing we can do. It will. Okay, tomorrow we'll discuss the project itself in the class. Whatever that issue that you are facing, we can sit and discuss on that issue. Because it's very hard to in the online to like to guide you on that. Okay, then we can leave the class. Thank you.